Hello, my name is Alyshia Bustos, and today I'm going to introduce you to interactive murals and how they can provide new opportunities for collaborative STEAM learning. This work was conducted in the Hand and Machine Lab at the University of New Mexico and is funded by the National Science Foundation. So for those of you that may be wondering, what is an interactive mural? It is a mural that blends traditional mural practices and ubiquitous computing. It contains embedded electronics, including sensors, actuators, and microcontrollers. Users can interact with the mural using touch or motion, and it will respond back to their interaction with it. This is an interactive mural that we created on the exterior wall of our partner organization. It stands 10 feet tall and 32 feet wide. We focused on local plant life as a visual theme. This mural incorporates touch, light, and sound interactions. In the summer of 2022, we held an intensive 5 hours per day, 4 days per week, 6-week workshop during which 4 high school youth designed and constructed this mural. So we aimed to expand the potential of wall-based interfaces by connecting them to culture, community, and learning by creating community-based interactive murals. We also aimed to investigate how interactive murals can be compelling and novel works of art by blending technology with traditional murals to enable new kinds of expression along with new kinds of interactions. We also aimed to determine that interactive murals can serve as rich sites for STEAM learning. We believe they can provide engaging entry points for learning electronics and programming as well as art, particularly for minoritized youth and communities with rich mural painting traditions. And lastly, we aimed to structure a project that was deeply situated in an existing public arts community in which minoritized youth learned fundamental skills in electronics and programming. So today, I'm going to focus on 2 of the outcomes of this project, STEAM learning and collaborative learning. First, I'll discuss how we documented student learning in electronics and programming over the course of the workshop, verifying that interactive murals can serve as sites for STEAM learning. Second, I'll focus on the opportunities that they provide for collaborative learning. I'm first going to discuss the people involved in this work. So a little bit about me. I'm an HCI researcher and PhD student in the Hand and Machine Lab at the University of New Mexico. I'm also the lead technology designer of this project. I collaborated with the wide world professional muralist Nanibah Chacon. She was a trained educator for 7 years before becoming a professional artist, and she has a long history of collaborating and teaching local youth how to create traditional murals. So for this project, we partnered with Working Classroom, a local nonprofit arts organization. They were founded in 1988 and have a long-standing mural program in which local muralists and youth collaborate to paint murals across the city. They are located in a diverse, low-income neighborhood and serves youth ages 11 through 18. So another important collaboration was with the group of high school students who were co-designers throughout the project. All of our students were existing members of the working class community who were recruited individually by Working Classroom staff to participate in our workshops. 4 students participated in the summer workshop, ranging in ages from 15 to 19. But I'll now lead you through the workflow of our project. So before the summer workshop began, Nani and I developed a workshop plan, and we aimed to develop a workflow that would help the students participate successfully as co-designers and co-authors of the mural in both the artistic and technical domains. This entailed providing clear and specific guidelines that would enable each student to contribute individual elements to a cohesive mural design and enable students to leverage and build on technical skills that they developed in a previous workshop that we conducted. Nani developed the thematical focus of the mural, orienting the visual theme and a companion set of design activities around local plant life. I designed the technical constraints, choosing to focus on interactions based on touch, light, and sound. So students participated in a series of activities designed by Nani to develop a collaborative and coherent visual design. They began by exploring the neighborhood, taking photographs of local plants and recording sounds. Then they sketched these plants, building the foundation of the visual design. Next, they worked together to combine their individual sketches into a cohesive visual design, which the students later extended to include local fauna. As the visual design came together, students began to develop a plan for the interaction design. They determined how different light patterns and sounds would be activated by touch. Once the high-level design was finalized, the students created an electrical layout. Each student, working with one circuit playground, LED lights, and touch sensors, were in charge of creating an electrical layout for a section of the mural. After finalizing all aspects of the design, students began the construction by installing electronics on the wall. Students programmed and tested sections of the wall as the electronics were installed. And finally, students painted over the installed electronics. Troubleshooting and programming continued during this phase of the construction. So our completed mural was unveiled during a citywide art walk at the end of the summer. The mural unveiling was attended by students and their families and friends and other community members. So we carefully documented each aspect of the spring and summer workshop. After each workshop, I conducted 1-hour semi-structured interviews with each student participant. And to analyze the interview data, I worked with Mia Shaw, a comic artist, STEAM educator, and postdoctoral researcher focusing on the design of STEAM learning environments for Black and Brown youth. And I want to mention that the interviews that we did with the students, we will later refer back to quotes from those students, and all the students' names are pseudonyms. And so based on the analysis, we arrived at 7 primary codes and 17 subcodes. The final round of analysis focused on developing thematic categories concerning students' learning in the context of creating an interactive mural, which 4 central themes emerged. So due to the amount of rich data, though, we collected and analyzed, this work focuses on the last 2 themes, STEAM learning and collaboration. We want to note that the fact that these 2 themes are intertwined with each other and the other 2 themes. Collaborative learning environments support students in STEAM learning. Combined, these themes facilitate deep engagement and help students develop technological and artistic knowledge and skills. We aim to expand and examine student agency, cultural expression, and community engagement in future publications. And so we have 2 main focuses for this presentation. So first, how this project focuses on engaging diverse students in integrated technology and art STEAM activities that support technical learning and positive shifts in students' perspectives, and how this work fosters collaboration by creating a rich social ecosystem and leveraging large-scale murals that help students navigate complex problems together respectfully and generously. And to assess learning and programming and electronics, we refer to the K-12 computer science framework, and we employ the co-measure assessment rubric that was developed by Harrow et al. To assess collaboration in STEAM learning activities. And so we wanted students to develop fluency in building electronics and programming by participating in our workshops. We wanted to support computational empowerment, helping students view electronics and computation as creative materials they could access, understand, and control. Our activities were designed to provide a context where minoritized students could develop skills and interest in these new areas in a familiar and supportive environment free of stereotype threat. So students demonstrated that their ability to construct and design circuits developed significantly over the course of our workshops. Students also developed soldering expertise and began learning how to use electronic troubleshooting tools, including a multimeter. Enrique recalled, we individually tested all of the lights after we cut them to size, and when they didn't work, we had to test them with the multimeter. They were also able to talk confidently about what tools and techniques they would need to use on electrical problems. Alexa mentioned, we had to solder the LEDs, those little stripped ends together, and then that took a while. And then once it was on the mural, we had to solder the copper tape, and then we had to solder our own circuit boards. I think I'm pretty okay with soldering. The students were also guided through activities that touched on fundamental programming concepts, including variables, conditionals, and loops. From the programs we collected, we were able to observe a clear progression in the programs students wrote over the course of the workshops. The code on the left-hand side of the figure shows the first program a student wrote for her interactive painting. The code on the right-hand side shows the final interactive painting program that she developed on her own. Students developed significant programming skills through their work on this interactive mural project. Students' perspectives on computing and its relationship to their interests and identities began to shift in subtle but powerful ways. Elena mentioned, before I wasn't really the person that'd be coding anything or wiring. Nothing like that. But ever since we did this workshop, I'm starting to look at things. Like I was putting up these fairy lights in my room, and I'm like, I'm wondering how you program these. I've learned new things, and I've learned things that I never really thought I would be able to do or really have an interest in. I want to do another one, and it's just really cool. So we found that the large scale of murals facilitates and requires collaboration, providing novel opportunities for students to support and learn from each other. So the design and construction of our interactive mural provided many rich opportunities for collaborative learning while still providing students with spaces for agency and self-expression. These began with the mural's visual design. This collaborative making activity grounded in peer interaction was crucial in designing a collaborative yet cohesive visual design. Elena described the process eloquently. At first, we were trying to fit every single plant that we drew inside. It was kind of like a puzzle, trying to figure out which plants would look good together. Everyone was throwing out ideas. At first, everyone was shy. And then we were all like, well, how do you feel about this or this? And then we were like, oh yeah, that looks good. Everyone at the end loved it. The students' collaboration on the visual design led naturally to collaboration on the interaction design. Students worked together to develop several whole mural interactions. For example, when a user presses the far left touch sensor, all the bugs across the mural light up. Some of these interactions required the additional of new visual elements, which the students discussed and then added to the design. Elena designed an interaction that led to the addition of a row of dandelion seeds at the top of the mural that was embraced by the other students. Elena mentioned, I had the idea of putting LEDs on the dandelions going up, and I said whenever they touched the sensor was being touched, then light would go up on the dandelion, and then the little offspring dandelion would light up, going with the wind that way. I wanted it to be one after another, like then one off the line of offspring would turn on, and then the next one. The scale of the mural also shaped the electronic installation. Many electrical components, LED strips spanned large areas across the mural. Students had to work together to attach these to the wall. Alexa describes this collaborative process of problem solving. She mentioned the challenge was having the copper tape stay together and figuring out where to solder. So I just had to rip off a piece of copper tape and place it next to the rip to remind myself there's a rip I would need to solder. So we believe that the fundamental collaboration between the primary organizers, characterized in part by a deep mutual appreciation for the artistic and technical components of the project, helped model and facilitate student collaboration. We believe that the multi-layered nature of our collaboration is intellectually significant. The project has been mutually beneficial to both researchers and artists. We believe that projects like ours can be beneficial and influential to students and communities, but their success depends on the depth of the collaborative relationships that are established between all parties. The enormous scale of murals affords collaborative design and construction. Integrating technology into a traditional mural added a new layer of collaboration between artists and technology designers in this project. In addition to successfully engaging a group of youth, each workshop needed to support and integrate students' different perspectives, interests, and skills. We believe that providing minimal, guided, open-ended, and student-led activities early in the workshop established the collaborative dynamic that students then maintained for the rest of the session. Since the electronic layout and interaction design were guided by the visual design, students naturally continued to collaborate around these elements of the project. While the affordances of interactive murals provide unique opportunities for collaborative learning, our experiences helped us understand how carefully pedagogical choices can emphasize and deepen those opportunities. The amount of planning and undertaking that went into organizing the project was extensive. From a research perspective, we believe that it is important for HCI researchers to undertake complex real-world projects like this one. In summary, we have identified distinctive learning affordances of interactive murals, highlighting how they provide deep support for collaborative learning. We propose the process of building an interactive mural as an intrinsically collaborative endeavor, which unique affordances arise from murals' large scale and interdisciplinary character. Thank you for listening to this talk.